Hello everybody, we're going to get started. Today we're going to be talking about Morningstar solar charge controllers and inverters for off-grid systems. This is Mark McHenry, and joining me today is Applications Engineer Doug Grubbs, who will help answer your questions at the end of the webinar. So if you have any questions during the presentation, please type them into the chat box located at the bottom of the GoToWebinar pane, and we'll address as many as time allows at the end. You can see the agenda in the lower right part of the slide. I'll start off with a brief introduction about Morningstar and an overview of solar controllers and inverters. Then I'll cover PWM versus MPPT controllers, efficiency and oversizing, some examples of Morningstar products, and we'll end with some Q&A. Who is Morningstar? So Morningstar is a U.S. company. For more than 20 years, we've been a leading supplier of solar charge controllers and inverters with the same ownership, management, and distribution partners since the beginning. We pride ourselves on our product quality, and over 3 million Morningstar products have been supplied worldwide since our founding. The off-grid power applications that use Morningstar controllers are remote sites that aren't connected to the electric grid. There's no utility company involved. All power has to be generated by a system at the remote site. And the main reason why people build off-grid systems rather than connecting to the electric grid at a remote site is predicated on cost. It costs approximately $15,000 US per mile of wire to connect to the grid. And this cost can be higher if there's difficult terrain involved, such as mountains, rivers, or forests. There are different sources of off-grid power. For high power needs, systems using fuel generators are often a good option. One problem with this, however, is the cost of fuel and the cost to transport fuel to the site. Another problem is the CO2 emissions from fuel generators. Secondly, you see wind and hydro systems are often considered, but not all remote areas have consistent or adequate wind and hydro sources. And then thirdly, if the power needs are not too high, as in the applications that we're going to see on the next slide, solar is an excellent source of power. And in places that experience a limited amount of sunshine, hybrid systems that combine solar, wind, hydro, and or fuel may be used. On this slide, you see some examples of applications where our charge controllers are used. In addition to residential and mobile home systems, Morningstar products are used in industrial applications at remote oil and gas sites, telecommunication sites, for remote monitoring, traffic, lighting, and railroad sites. These applications differ from the grid-tied systems that most people are used to seeing in their neighborhoods, where the homeowners are selling back power to the utility company. Likewise, the solar panels and systems that people see on top of some football stadiums, these are also generally connected to the grid, so these aren't the same as the off-grid applications where Morningstar products are used. The diagrams on the next couple of slides will give you a better idea of how our products fit into an off-grid system. So let me go ahead and move forward. And this diagram displays the controller and other components of an off-grid system and how they're connected to power a direct current DC load, such as the light in this example. So what's happening here is sunlight contacts the solar modules, and this is going to convert solar into DC electrical power that it delivers to a charge controller. Charge controller regulates the amperage and voltage that is delivered to the loads, and then any excess power is delivered to the battery system. And this is so the batteries maintain their state of charge without getting overcharged. During the evening, when there is no sunlight, battery power is then used to run the load. Notice that the battery here is grounded at the negative battery terminal. And this is because all of our PWM and MPPT controllers have a common negative ground. Therefore, it's possible to establish common negative ground for the entire system. That's the solar array, the battery, and the load. This meets NEC code requirements for grounding. If you need an equipment ground for any metal parts on a controller enclosure, some of our controllers include an equipment ground terminal lug. Otherwise, for our controllers that don't have this terminal lug, you can connect an equipment ground directly to the controller enclosure. And on the next slide, we're going to go ahead and take a look at a diagram that relates to loads that run off of alternating current or AC power. This diagram with an AC load looks very similar to the previous example with a DC load, except that in this example, we've added an inverter to the system. That's the sure sign inverter right here. The purpose of the inverter is to convert the DC power from the battery to AC power that can be used to run an AC load, like this TV you see on the slide. And we're going to showcase a pure sine wave inverter a little later in the presentation, but for now we're going to stay focused on charge controllers, and we're going to look at the charging stages that controllers put batteries through. So this graphic illustrates Morningstar's multi-stage battery charging process. The first stage that you see here is bulk charging, delivering 100% of available solar power to bring the battery up to a state of charge of approximately 80 to 90%. And when the battery reaches the absorption voltage set point, constant voltage regulation is applied. This prevents heating and excessive battery gassing while the battery reaches a full state of charge. During the absorption stage, the charge current reduces as it requires less power to maintain the regulation voltage. And when absorption charging is complete, the battery has about 98% state of charge. Then the charging current is reduced further, so the battery voltage drops down to the float voltage. The float stage keeps the battery full for maximum capacity through to the end of the day. For flooded open vent batteries, an equalization charge is applied once every 2 to 4 weeks to maintain consistent specific gravities among individual battery cells. And the more deeply a battery is discharged on a daily basis, the more often equalization charging is required. Important to note that equalization is for flooded, not for sealed, gel, or valve regulated batteries, which can be damaged by equalization. And this slide pertains to lead-acid batteries. Other battery chemistries may have different charging requirements. Although lead-acid batteries are most common in off-grid solar systems, lithium and other battery chemistries are starting to gain traction. You can custom program for the lithium-ion battery types you see here on this slide, and also for other battery chemistries that we'll see on the next slide. So what you're taking a look at here, you see nickel batteries and other battery chemistries that can be accommodated by some controllers. Talk a little bit more about the solar charge controller. A charge controller maintains the battery at its highest state of charge while protecting the battery from overcharge by the array. Some controllers include load control for low voltage disconnect to protect the batteries from over discharge. In addition, there are daily on-off lighting control options. Charge controllers can also provide system status indicators with meters and LEDs to display battery voltages, current, system operating temperatures, and alerts. Additionally, some controllers include data logging as well as remote monitoring. Charge controller generally represents about 10% of your total system costs, and a good controller will extend battery life And batteries can be 40% of your first-time cost and about 80% of your lifetime cost. A poor controller can cause battery failure and complete failure with your entire solar system. So you can have the best batteries and the best modules in the world, but they're only as reliable as your controller. Now that we've completed a general overview, let's go ahead and take a look at two main types of solar charge controllers. And the two major types of solar charge controllers are pulse width modulation, or PWM controllers, and secondly, maximum power point tracking, or MPPT controllers. So looking at this table here, we'll start with PWM controllers. PWM controllers operate at battery voltage. For PWM controllers, if you have a 12-volt nominal battery that you see here, you would use a 36-cell module, which is a 12-volt nominal array. And of course, the controller needs to be able to charge 12-volt batteries. And then for a 24-volt battery, you should use a 72-cell module or two 36-cell modules in series. And then lastly, for a 48-volt battery, you can use two 72-cell modules in series or four 36-cell modules in series. MPPT controllers, on the other hand, operate at maximum power voltage, or VMP, of the PV array, which is higher than the battery voltage. The controller converts the incoming high VMP voltage down to battery voltage to charge the battery. And while the voltage leaving the controller is lower, the amperage is higher. And by being able to operate at VMP, MPPT controllers can generate more power than PWM controllers that need to operate at a lower voltage. Morningstar controllers include very fast tracking, which means that the controller will continuously operate at VMP during bulk charging to deliver the maximum power possible from a given array. And on the next slide, we're going to go ahead and take a look at a chart that compares PWM with MPPT controllers. So you see on this chart, PWM controllers tend to be smaller and they operate at battery voltage, whereas MPPT controllers operate at the maximum power voltage. This maximizes the amount of power being produced, which becomes more significant in colder conditions when the array voltage gets increasingly higher than the battery voltage. MPPT controllers can also operate with much higher voltages and lower array currents, which can mean fewer strings in parallel and smaller wire sizes since there is less voltage drop. PWM controllers need to be used with arrays that are matched with the battery voltage, which limits the modules that can be used. There are some 60-cell modules with VMP equal to about 30 volts, which are simply not compatible with PWM controllers. The advantages of MPPT over PWM controllers come at a cost, so sometimes a PWM controller can be more cost-effective with smaller systems and in warm climates where the MPPT boost is not as significant. And on this slide, you see our family of Morningstar PWM controllers. From largest to smallest, we have the TriStar, ProStar, SunSaver Duo that's used for boats, mobile homes, and RVs. And then we have the Sunlight, Sunkeeper, and SunGuard. And we're going to take a look at the ProStar a little bit later because we do have a new generation ProStar, so we're going to highlight that a little bit on some future slides. But let's go ahead and just highlight a few of these PWM controllers that might be most relevant to our audience. So I'll go ahead and first take a look at the SunSaver controller. And the biggest differentiator with this controller is that it's suitable for use in environments where flammable chemicals may be present, present, so that's what this certified for use in hazardous locations, Class 1, Division 2. So this is often used at remote oil and gas sites to power electrical devices, meters, and process control equipment. It's also FCC compliant and very suitable for telecommunications applications. Typically, these would be small applications. It comes in 6, 10, and 20 amp versions for 12 and 24 volt battery systems. It's only about 6 inches long and weighs half a pound. And as I alluded to earlier, you see here the recently launched 3rd generation ProStar and the 2nd generation model of our ProStar PWM controller. The first ProStar was introduced over 20 years ago, and some of the earlier generation ProStar PWM controller models are still in operation today. This product can be used in virtually any residential, mobile, or off-grid industrial application. It comes in 15 or 30 amp metered and non-metered versions to charge 12 or 24 volt battery systems. And on the next couple of slides, we're going to go ahead and take a look at the upgraded features and capabilities that have been added to the 3rd generation model that you see here. So unlike the Generation 2, or the Gen 2, the new ProStar Gen 3 has an RJ11 MeterBus port, enabling data logging, and you can connect the Gen 3 to a computer or the internet. The Gen 3 has programmable lighting control, 7 standard charge settings plus a custom setting versus just 3 standard charge settings for the Gen 2. You can make firmware updates by computer in the field with the Gen 3. And the Gen 3 has an external remote temperature sensor terminal on the controller face. And then lastly, on this slide, you see the load control is adjustable on the Gen 3. We'll take a look at some additional differences between the ProStar Gen 3 and Gen 2. So you see here the Gen 3 has a protective terminal cover. PWM noise can be easily eliminated by pushing a dip switch on the Gen 3. This can be helpful in telecommunications applications or also in boating applications. The Gen 3 has enhanced self-test and diagnostics. It's compliant with IEC 62109 and has increased load surge capacity. And lastly, the Gen 3's metered versions feature a larger, more robust and advanced meter interface. And this is a very huge difference. The Gen 3's meter is larger and has a backlight, so it's easier to use. It also can be displayed in multiple languages. That includes English, Spanish, French, and German. You can easily adjust charge settings with this meter. So you can adjust LVD and lighting settings in the field with the interface. And the meter interface is very intuitive and easy to navigate. The meter can display graphical information such as data logging of maximum and minimum battery voltage over time and other metrics over time. And then next we have the TriStar PWM controller. It's a very, very popular controller. It supports 3 operating modes: solar charging, load control, or diversion control. But you can't use one TriStar to perform all of these operating modes in your system at one time. Therefore, if, for example, you needed charging control and load control in your system, you'd either have to install 2 TriStars, or more likely you would install 1 TriStar for charge control and a smaller controller like our SunSaver or ProStar for the load control. It operates at full ratings to 60 Celsius without the need to derate. Versions of this controller include 45 amp or 60 amp at 12 to 48 volt battery systems. It's used a lot in residential applications, also lighting, traffic, and railroad applications. You see here it's equipped with extensive electronics protections. It has an RS-232 connection for custom settings, data logging, and remote monitoring. So those are a few of our PWM controllers. In the next slides, we're going to go ahead and look at our MPPT controllers. So from left to right, we have the TriStar MPPT 600 volt controllers. Next, the TriStar MPPT, the ProStar MPPT, and then the SunSaver MPPT controller. All of the Morningstar MPPT controllers use TriStar technology to sweep the array, and I'll go ahead and talk about that a little bit later. Let's go ahead and take a look at our SunSaver MPPT controller first. It's about 7 inches long and weighs just over a pound, so it's very easy to handle. It's rated at 15 amps. Maximum input operating power is 200 watts and 400 watts for 12 volt and 24 volt battery systems respectively. It provides a 5 to 25% charging boost and increases battery life. Some people like to use this with a 24 volt nominal PV array to charge a 12 volt battery. And this controller reduces power losses in long wire run systems. Peak efficiency you see here on this slide is 97.5%. And the controller is often used in residential, lighting, traffic, and railroad applications. This is our newest MPPT controller, the ProStar MPPT. Here you see a picture of a non-metered example on the left here and a model with a built-in meter on the right. The non-metered and metered ProStar MPPTs come in 25 amp and 40 amp versions. The 25 amp versions have a 25 amp solar charge rating and a 25 amp load rating. And the 40 amp versions have a 40 amp solar charge rating but a 30 amp load rating. And this device has automatic battery voltage detection, a max VOC input voltage of 120 volts, very wide operating temperature range, and a 98% peak efficiency. ProStar MPPT has the largest meter interface of all Morningstar controllers. It can be used in the field to set charge control, load control, and multi-event PV-based lighting control. It accepts multiple language inputs and performs automatic self-diagnostics to alert about installation errors. The device has ModBus communications capabilities, also data logging up to 256 days, and a temperature fallback provision to accommodate lithium batteries. So for example, you can set the fallback temperature to 0 Celsius, and as the temperature decreases towards freezing, the controller will reduce charging and ultimately cease charging at 0 degrees to prevent harm to the lithium batteries. What we're looking at here is the optional wire box accessory to the ProStar MPPT. And like the controller, this is made of polycarbonate Lexan material, so it's very durable. And replacing the standard cover with this optional wire box cover gives you a lot more room for larger wires and conduit. The terminals you have to remember on the ProStar MPPT, the terminals are rated for number 2 AWG, and this wire box has enough room to support these large wire sizes, whereas the standard cover on the ProStar MPPT will accept a maximum wire size up to number 6 AWG. So some inspectors may require this cover to reduce hazards associated with exposed wires, conduits, and connections. And what we have here is there's 4 concentric 1/2 inch by 3/4 inch knockouts or glands on the bottom here and there's one on the side here and another on the side here. And then in the middle you see here there is one 3/4 inch by 1 inch knockout. And here's the TriStar MPPT. It comes in 30 amp, 45 amp, and 60 amp versions. All versions of this controller support 12, 24, and 48 volt battery systems. The peak efficiency of 99% is among the highest, if not the highest in the industry. The TriStar MPPT is commonly used in residential, telecom, and railroad applications. Our largest controller, the TriStar MPPT 600 volt controller, this was created for input voltages greater than 150 VOC, systems with long wire runs or greater radial bends from the power input to the controller. If you need to increase the size of your PV array, you can add modules incrementally without incurring string sizing issues associated with smaller controllers. Its peak efficiency of 97.9% is very high for a high voltage controller. It's preset for 48 volt battery systems, but it's custom programmable for other battery system voltages. The controller is used in residential and telecom applications. You see pictures of the standard version, also versions with the disconnect box, transfer switch, and the pre-wired ground fault protection device on the far right. And the transfer switch version of this controller is a major component of a solution that provides battery backup power in residential and light industrial grid-tied solar systems. If you want more specifics about how this backup application works, I invite you to search Morningstar Backup, where you will see a page with a video and additional information about this. Also, feel free to chat any questions about this or go ahead and contact us on our MorningstarCorp.com website. So let's look at some common characteristics of Morningstar solar charge controllers. So all of our controllers have a 5-year warranty unless otherwise specified. We're supported by select wholesale distributors. Many have been with us since our inception. Also, our controllers are manufactured in a certified ISO 9001 facility and subjected to strict quality control guidelines. You can see here that our controllers are passively cooled and have no fans or moving parts. That can be a point of failure. And this also keeps dust away from the circuit boards. Our controllers perform very well through a wide range of temperatures, from well below freezing to well above room temperatures. And they have lighting and transient surge protection. Morningstar is easy to integrate with all types of solar modules, batteries, inverters, and other balance of system components. With factory presets or saved custom settings, our customers often say you can just set it and forget it. Environmental protection associated with Morningstar controllers include epoxy encapsulation and conformal coating. And to illustrate a point about epoxy encapsulation, I'm going to use an example of our SunSaver controller here. In the picture that you see now, the cover is on the controller. But now I'm going to show you a picture of the cover off so that you can see the epoxy underneath it. This epoxy protection is like hard plastic that completely covers and isolates all the electrical components and the PC board. And this protects against humidity and airborne particles. This is the best practice for electrical device manufacturing. Many control brands don't have this protection, but Morningstar controllers do. Conformal coating is applied by a spray that goes over the circuit boards to protect against dampness and corrosion. So this nozzle that you see here, this sprays a fine mist of epoxy or silicone coating, and it's going to go ahead and travel up and down this entire circuit board to apply a coating that will provide additional protection against moisture, dust, and other contaminants. We also use surface mount components that are precisely assembled by machine, not hand assembly. So this makes for a very reliable, high quality product. And next we're going to go ahead and take a look at how the efficiency of a Morningstar controller varies at different power output levels. So efficiency is a ratio of controller output power to input power from the PV array. Or another way of looking at it, it's how much power is lost by the controller in the form of heat because of inefficiencies. So you see how on this MPPT controller graph of efficiency versus output power, the Morningstar controller that is represented by the orange line on top, this provides significantly higher efficiency at both low and also high output power levels, whereas the other controller's efficiency, represented by the blue line here, you can see that the efficiency drops off dramatically at output power levels away from its near peak efficiency. You can see how the Morningstar controller reaches peak efficiency very, very quickly and then remains at high efficiency throughout all power levels on the graph. Other MPPT brands have been shown to have more than 2 times the energy losses at higher output power levels. So when a manufacturer quotes you a conversion efficiency for a controller, you need to know the output power at which that efficiency was calculated, and also how much that efficiency will vary at higher output power levels. In a grid-tied system, a 0.25% difference in efficiency is a big deal. What we're talking about here, we're talking about 1 to 3% difference, which is a huge difference. So really you have to appreciate what might otherwise be perceived as a small difference. 99 and 98 might sound pretty similar, but when you're talking about efficiency, it's a very big difference. Another way to look at this is twice as much energy is being lost in the form of heat in the 98% scenario. So let me go ahead and close on the topic of efficiency and move on to a different topic that involves array oversizing and Morningstar MPPT controllers. The point I'm about to make here about array oversizing only applies to our MPPT controllers, not our PWM controllers. I'm going to go ahead and use our SunSaver MPPT controller as an example, but this point about oversizing also applies to our ProStar MPPT and TriStar MPPT controller families. So in this example, the SunSaver MPPT that you see here has a nominal maximum operating power of 200 watts, but using a 240 watt module won't damage the controller and won't cause it to exceed its rated 15 amps of output current. Just bear in mind that you still have to adhere to the other operating guidelines in the Morningstar manual. So for example, you must never exceed open circuit voltage limits listed in the manual, because this will damage the controller. You can read more about array oversizing in a white paper at the link that's on the bottom of this slide here. And on the next slide, let's take a look at a graphical view of what's going on in this example. So we're going to go ahead and create a graph of operating power versus time of day for the SunSaver MPPT controller that has a maximum operating power rating of 200 watts. We are comparing performance of a 200 watt module represented by a black curved line to that of a 240 watt module represented by a blue line. And this is an operation on a clear, sunny day at standard test conditions and maximum power. If using the 240 watt module, although the power being delivered to the battery is limited to 200 watts, and the red area at the top of the production curve represents lost power, the larger 240 watt module is still harvesting more energy than the 200 watt module as shown in green. The larger module will provide better production with no power shaving early and late in the day as compared to a smaller module. So in this case, almost twice as much energy is gained in the green area than is lost in the red area, and you get about 12.5% more energy available to charge your batteries than you would with the 200 watt module. Again, this is on a clear and sunny day. Well, what happens on days when it isn't clear and sunny? So we'll go ahead and take a look at the next slide. And this is a graph using real array data to depict what happens on days with intermittent sun and clouds for the 200 watt and 240 watt modules. So on these days, there's going to be little or no power shaving, and the extra power will serve the battery well with more energy harvest. On this day for the 240 watt module, there's less than 1% loss due to power shaving. That's the energy above this red line. So almost all the excess power over the 200 watt module can be utilized for charging. So systems that experience a lot of intermittent sun and shading during the day are definitely very good candidates for oversized arrays. Another common feature of every Morningstar MPPT controller is the TriStar algorithm that ensures fast and accurate tracking of the array's true maximum power point at all times throughout the day. Every MPPT controller uses an algorithm to determine the array's maximum power point. TriStar MPPT controllers with TriStar technology may provide 2 to 7% or even more charging energy on a daily basis from the same array compared to other MPPT controllers on the market. This is because of better energy harvest from better tracking throughout the whole entire day. TriStar algorithm is very accurate and extremely fast. It sweeps or evaluates the array's maximum power point in a fraction of a second as compared to other tracking algorithms that might take 10 seconds or even up to a minute. And on the next slides, we're going to go ahead and take a look at the Morningstar SureSign inverter and product accessories. Here you see our SureSign off-grid inverter. It's ideal for rural electrification, telecom, mobile and marine installations requiring AC power. It has a low self-consumption of 450 milliamps when powering loads. During no load conditions, the SureSign automatically powers down to standby mode and self-consumption is reduced to 10% of operating consumption. It's available in 115 volts at 60 hertz or 220 volts at 50 hertz output versions. It provides 300 watts of continuous power, has a 600 watt surge, and the SureSign has a 12 volt input. It's highly reliable and it's equipped with an environmentally ruggedized chassis design. What you're taking a look at here on this slide is a new accessory from Morningstar that was announced on September 1st. This Ethernet MeterBus Converter, or EMC-1 device, converts a serial connection to an Ethernet connection, enabling compatible Morningstar products to be connected to an IP network and the Internet to facilitate remote monitoring and remote system settings adjustments from almost anywhere in the world. It's compatible with all of our MPPT controllers, as well as our TriStar PWM, our new ProStar Gen 3, also the SunSaver Duo PWM controllers, and our SureSign inverter. You can see in this diagram how connections are made with the RJ11 cord between the Morningstar product on the right and the EMC-1 in the middle. And the EMC-1 is connected to an Ethernet gateway, which is typically a router or switch that you see on the left. So for example, many of you might have legacy Morningstar products that up until now couldn't connect with an IP network or the Internet. But now if you connect the Morningstar controller or inverter to the EMC-1, You can view remotely in your web browser many useful system metrics such as battery voltage, PV current, load current, faults or errors within the system. And this information will appear live in real time, so you see data changing without having to refresh your browser. Furthermore, you'll also have writing privileges to change your battery charging settings, your low voltage disconnect settings, and lighting settings. This slide here displays our other product accessories, including a ground fault protection device, optional meters, communication adapters, and remote temperature sensors. And if you go to our support site, that's support.morningstarcorp.com, and you search for accessory, you'll see a chart that will let you know which accessory is compatible with each Morningstar product. Let me share some information about another useful tool on our website, the Morningstar String Calculator. If you type in string in the search bar of the MorningstarCorp.com website, you'll be directed to our string calculator. I definitely recommend that you bookmark this site, string-calculator.morningstarcorp.com. You see right here. And this calculator lets you know how many modules you can arrange in series and parallel for a given type of module, battery system, and Morningstar charge controller. So to sum things up, all controllers are not equal. Amperage and voltage ratings differ, and charging algorithms and advanced features and protections vary among different products and brands. Charge controllers provide core functionality to solar power systems to maintain healthy and long-lasting batteries. A failed controller can cause failure in your entire PV system. For over 20 years, Morningstar has been focusing on designing and providing high-quality, reliable products for off-grid systems through global distribution. We've had the same ownership, management, and strategy since 1993. Many of our distribution partners have been with us since our inception, and we rely on them to provide pricing information, service, and technical support for your entire system. Okay, so it looks like we reached the end, and now it's time for the questions. So Doug, if you want to go ahead and take yourself off mute, I'm going to bring up the questions. And for all those that are attending, if you have additional questions, feel free to enter them in the chat box, and we'll address them here as time permits. And if we can't get to them, we'll definitely get back to you after the webinar via email. So let's see what we have here. I'm going to go start at the top here and work my way down. Let's see. Okay, so yes, we can provide a recording of this webinar will be provided. You'll get an email within the next day or two with the recording. Also, we can get out the slides to you if you need the slide presentation. I have another question here from Ruggiero. It says, what is the DOD for which model?
So I think he's asking about the depth of discharge for LVD, possibly. Yeah. So the depth of discharge typically will vary a little bit because we have a voltage-based low voltage disconnect. And so this can be affected by temperatures, by size of the loads. We do have current compensation on our LVD, so that is taken into account to some extent. However, you know, if our settings are about, you know, our default settings are usually 11.3 to 11.7, I've seen for some of our settings. So the default settings are generally set somewhat low, not too low though. I mean, we hit requests for LVD settings lower from some people and higher from other people. So This is a pretty common setting, around 11.5, 11.6 volts, where your batteries are maybe a 25% state of charge or 75% depth of discharge, maybe 80% depth of discharge, depending on conditions. In very cold conditions, it actually can be at higher state of charge, which is a good thing because you never want to have dead batteries in freezing conditions. So it can be adjusted, and that's one of the settings that's very easy to adjust with our custom settings, either in MS View or with the digital display on the ProStar and ProStar MPPT. You just can go in there, create a custom settings profile, and then set the LVD setting however you would like. Some people prefer a 50% state of charge, which might be 12 to 12.1, 12.2 volts, and depending on your battery, depending on your system. But that would be to prevent it from over discharging, and the life of the battery can be affected by how deep of a discharge you make with your batteries. However, with our settings now, if you size the system correctly, it shouldn't get to that lower voltage very often. So even though it's set for a lower voltage, it might only happen occasionally. So you're not deep discharging on a constant basis. So how much that will affect your life of your battery might not be that bad if it only happens a few times a year that it gets below the 50% state of charge. So there's a lot of things to consider with your low voltage disconnect settings, but the main thing is that 11 point, in the settings, that the default settings will prevent damage to the batteries, and that's the main consideration with that.
Okay, very good. I have another question that came in here. It reads, for MPPT charge controllers, current in is less than current out. How much difference? How much? Let's see. How much percent that current in is larger than current out? So this relates to a slide that I talked about regarding the MPPT controllers and the fact that it does a DC to DC conversion.
Yeah, so the input's always going to be less than the output because the input has to be higher voltage. The total power out can't be higher than the input, so that means with higher voltage, the current always has to be lower on the input. There'll be a ratio between, you'll have kind of a opposite ratio for current than you would for voltage. So if you have like a 2-to-1 ratio for voltage, you'd have basically a 1-to-2 ratio of the current. So it's going to be the exact opposite of the voltage. So with much higher voltages, you'll have much lower input currents. Then the next question this person had was, what's the max power or the max current input? There's the max input can never actually operate higher than the max output, even if you put a higher rated array. If you have an ISC and IMP higher than the output, max output, it will not operate above the, it'll be limited based on the output current. So, if you had a much higher input current, of course you're going to lose a lot of power. A whole lot of power. Anything higher than the output would be pretty rare because you're just going to be power shaving quite a bit. So you generally want to use a input that would be less than the rated output. It is possible to use a higher rated input, possibly, but you would want to have a fuse on the input if you did that. The NEC isn't really written for this kind of application, since Generally, solar is made to operate at maximum power or at battery power. So you're talking about voltages in the IMP range. Once you start reducing that, you're pretty much not taking advantage of your whole solar array. So generally, you don't need to do that. If there's some reason why you want to do it, you can do it, and it would just limit the power to the output in order to protect against any short circuits that may happen. If there is damage in the system, you would want to have a fuse just in case there's a something that goes wrong with the system you would want to have a fuse on the input rated to the max output. So you wouldn't want to have a short circuit somehow and have that cause further damage that it needs to. So you'd want a fuse rated to the max output current. So if you had a 60 amp controller, you'd have a 60 amp input fuse on the input, probably a 80 amp or something on the output still. But there shouldn't be any problem with setting it up like that.
Okay, I have a question.
Even though the NEC doesn't really have rules applying to this.
All right, I have a question here about the SureSign inverter. It says this inverter has dual AC voltage of 150 volts or 220 volts. I guess the question here they're saying is, do we have to purchase one or the other, or can we purchase one and can it operate it at 115 or 220 volts?
So we have two versions of the SureSign inverter. One is the 115 volt and the other is the 230 volt. The 150 volt is a 60 hertz. I think we have a 50 hertz of the 230. Let me just check that real quick. He also, so the frequency of the inverter is not adjustable either. So you have to make sure you have the right frequency for the version you want also.
Okay. I see something came in from Delmos. Let's see. Okay, this just a comment mentions that he's had been using our products for over 8 years. Okay, thank you. Don't see a question there. If you have a question, feel free to chime in with it. Appreciate you using our products. Let's see. Someone asked a question about ROHS compliance, whether our controllers have that.
So the ROHS compliance, we have that, and I believe it's on our website. If you go to the product page in the support library docs, and you'll see ROH certification document in the corporate tab on the product support page. So we have ROHS certification documents available on our website.
Okay, and I don't know if you can get into it here, Doug, but is there anything about the association between if somebody already has CE, whether that covers ROHS already?
I think that's something different. The CE is for noise. It's compliance for noise, I believe, and the ROHS is regarding hazardous substances. So we have both of those available, and if you go to the corporate tab, I believe both of these are available. The IEC certificates, we have certificates for any of our products. If you don't see them on the support site, on the support for the product you're interested, you can contact us and we can send you the certification that you're interested in.
Okay, and I see another question. It says, which controllers are compatible with the EMC-1. That's our Ethernet MeterBus Converter. Well, let me see if I can pick up that slide here. I believe if I'm bringing this up. Yeah, okay, so we should have that here. So this gives a list of our products that are compatible with the EMC-1, TriStar MPPT, ProStar MPPT, SunSaver MPPT, TriStar PWM, ProStar Gen 3, not the Gen 2, but the Gen 3 that recently came out in January. Also the SunSaver Duo and SureSign Inverter. Okay.
And so, yeah, well, so this is really new for us to have this. At this point, we have port forwarding that you can set up. You can set up the IP on your router, the IP address for the product in your router. Having this is really nice, is because generally it's better than having a Ethernet to serial converter. It does the same kind of thing, but having this makes it more like you're plugging it into an Ethernet on the controller itself. This basically has all the software involved in it, and so the firmware in the EMC-1 will automatically turn your serial interface and also your RJ11. You don't need to have RS-232 serial interface anymore. You just connect it right to the RJ11. That's for the ProStar, SunSaver, ProStar MPPT, all these products except for the TriStar MPPT and TriStar PWM. You're basically using your RJ11 straight to an Ethernet, and that Ethernet is basically at this point the same connection as it is for your TriStar MPPT. So if you use the TriStar MPPT before, you're getting the same connection. Now the TriStar MPPT and TriStar PWM, you also have a Y connection, so you actually do have to make that RS-232 connection. But it's still as easy to set up as it was for the TriStar MPPT, basically the same. If you have a local area network, it will automatically find the controller because it will, the router will assign an IP address to the product, and as soon as you plug into your local area network, you will see it come up in the MS view, and it will detect it, and it's very easy to connect to products with this.
Okay, I see a question, a follow-up question comes in. Does the EMC-1 need to be hardwired from both sides? Let me bring up a slide here.
I'm not sure. Basically, you need an Ethernet on the left side here in this diagram, and you also need the RJ11. Now, with the TriStar and TriStar MPPT, you need the RJ11 connection and an RS-232 connection, which is a Y connector. It goes into the RJ11 connection. We also would recommend, it can turn on with the RJ11. It can power it for certain devices, but it's best to use the power supply from your battery. It's able to be used with any voltage battery. So it is a hardwire connection. Now, if you have wireless, of course, you're not going to have a wireless connection to this device. There are wireless gateways you can get where you would connect it to a wireless device. These are pretty commonly available, and it would have a wireless connection to your router. So that's sort of a gateway interface that you can add to it to get wireless from the Ethernet EMC adapter. You can pretty much do that with any Ethernet connection you want. So if you need that, there are wireless gateways for Ethernet. That shouldn't be a problem to use that.
Okay. And I have
we also see a lot of people using wireless internet connections with our products, or in locations where they want to get wireless connections. So that would require this type of wireless gateway, and then you'd have a wireless connection to a wireless network that would be, possibly somewhat remote.
Very good. So we do have another question I see came in from Edward. The question is, do you find that as PV panels degrade with time, it is possible to add more panels than the string tool specifies?
Can you repeat that?
Yeah, sure. The question here is from Edward. Do you find that as PV panels degrade over time, is it possible to add more panels than the string tool specifies?
Oh, sure. So the string sizing calculator, I want to back up on that. With an MPPT, it's no problem with oversizing. Now with the PWM, you never want to oversize a PWM. You never ever want to oversize a PWM because they are not rated to handle that much current. So you never want to exceed the current rating of a PWM controller. So that would not be a good solution, and you want to make sure you're following all the same array sizing and matching the voltages of different strings, matching the currents on any given string. So you always want to make sure you follow all the sizing rules, but you can pretty much oversize a MPPT controller pretty much as you want. At some point, it's not going to make sense to oversize too much because you're losing all that power. So you want to get more. If you want that full array power, then definitely use a second or even a larger controller for that.
Okay. So I see Edward specified that he has the TriStar MPPT 60. So as long as he is not exceeding VOC, because you can't do that, but yeah, he could oversize and exceed the current limits, and the software in our controller is going to make it so that the controller does not get damaged.
Yeah, and there is if you click on the sizing, so it turns out comes out red. We want to modify this so it indicates kind of a somewhat oversized compared to a very much oversized system. So we want to, if you click on that page, you'll see a link and more explanation that it could limit the output below the PMP at times. So your max power, you're not going to see the max power if it's not, if you've oversized it at times. So it does limit, and it's just giving you a warning that it will do that in case that's of a concern. Typically, some people prefer not to limit it, but there's a lot of people that, especially the grid-tied market, has greatly embraced this idea of oversizing the array in terms of cost considerations, and financially it makes more sense to oversize it a little bit. Now, if you're oversizing it all the time, there may be times when you will benefit from that extra power. So how much you oversize is really kind of to be determined by by you guys out there, whatever works for your best interests. So that's definitely something to consider.
Okay, well, that looks like we've taken care of all the questions. If you have additional ones, you can go ahead and contact us by going to our website and going to the upper right to the Contact Us button. I'll be happy to entertain any additional questions you might have. At this point, I'd like to just bring up this thank you slide, and of course you can go to www.morningstarcorp.com for additional webinars that are coming up or will be coming up, and also our recorded webinars. All right, thanks very much, Doug. Thanks all for joining. This concludes the broadcast. Take care.